Today we're going to do the first part of 5.5. This is about solving rational equations and inequalities. We're going to save the inequality part for tomorrow. Today we're going to solve rational equations, and we are going to apply those techniques to a real-world problem. Tomorrow we will solve inequalities. And we do need to remember that sometimes when we solve an equation, there are extraneous solutions. So an extraneous solution is a solution that you get from the original equation, but it's not an actual solution. So it looks like a solution. You solve, you find x equals a value or a few values, but then when you plug that value back in, okay, it's not an actual equation. Can you guys think of some examples of problems that could have an extraneous solution that it looks like an answer, but when you plug it back in, it doesn't work out? We talked about them. So what do we have to be careful of? This is related to the domain. What are the problems with the domain? There's too much squeaking going on out there. Okay, so what's the solution? Or what are some problems that have extraneous solutions? So what are situations where you get an error, right? We talked about those. What are some problems with the domain? Yeah.
The denominator can't be zero.
Yeah, exactly. Great. Okay, so if you have a fraction, so when you have a fraction, it has to have the variable in the denominator. Okay, so if the fraction had a number in the denominator, like if it was 1/4, that's fine because the denominator is 4. But if you had 1 over 4x, that is not fine because the denominator can't be 0. Great. Who else can give me another one? Yeah, Ashley? Yes, okay, when you have a log equation. Excellent. So if you have a log equation, the problem there is you can't take the log of what? Yeah, and what else? Nope. Nope. Something very close to a negative number. 0. Can't take logs of a negative number, 0. Okay, and then one more. You guys got this one. What's the last one? Yeah, square roots, because you can't take the square root of, and really this is for all even roots. We're going to talk more about even roots in 5, 6. So what's the problem with an even root? What can't you take a square root of? Yes. That's when the imaginary numbers come out. So you can't take the square root of negative numbers. Okay, so that's what we have to watch out for. That's when extraneous solutions pop up. So what we're going to do today is we're going to solve each equation. We're going to check for extraneous solutions, and then I'm just going to remind you of how you can do a very quick check to make sure it's not extraneous. So for A, we are going to solve x minus 18 over x equals 3. So we're still in chapter 5, so we're still dealing with these rational functions. We're still dealing with the fractions here. So if you're solving an equation, notice how you have x here and x in the denominator. You want to get the LCD of the fraction and make it one term. You don't want these two different terms here. Okay, so we're going to find the LCD. Can you guys tell me what it is? The LCD is here. Nope, because 18 is the numerator. So think of it like this. This would be like x over 1, right? So remember, with the LCD, just start with the first one. So 1 has to be in the LCD. What else has to be in the LCD? What's 1 times x? X. So x is your LCD. Sorry. I'm going to show you a couple different ways to do this today. So in the past, we would take each of these. I'm actually going to color code this for you. So this is x over 1 minus 18 over x equals 3. And then to get the LCD, we have to multiply. Okay, so you can multiply to get the LCD. So, because this one already has the LCD, you only have to multiply this one by x over x. So we've done this before, right? So x times x is going to give you what? X squared. So on the top, in the numerator, I have x squared minus 18. On the bottom, I have x. Because once you have a common denominator, you can just subtract straight across. Okay? Then you get here, and you have options. You can put this over 1, and you can think of it as cross multiplication, or you could multiply each side by what? Yeah, yx. Why would you multiply each side by x? Yep, so you're going to multiply each side by the denominator. Okay, so in this case it's going to be x. But then this is a rule you can apply no matter what you have. So if you multiply both sides by x, we can have some cancellations. My ASMR fans, get the whisk in there. All right, and then this you have x squared, negative 18, and 3x. So what are we going to have to do to solve this? That. So this one you don't want to divide because you have the x and the x squared, because that would eliminate one of your solutions. But if you have x squared and x, what could we do? No? That would make it bigger. Yeah. What did you guys say? Not yet. Factor. But in order to factor, we have to do what? Yeah, we have to move them all to the same side. Okay, so in this case, you're going to get all terms on one side. And that's because you can factor. So your clue that you can factor is going to be this x squared and the x. So if you have 3 terms that are not like terms, move everything to one side. And then, do you guys feel like you're really good at factoring now? After all the factoring we did last time? Okay, so I'm just going to bring this up here. The x squared minus 3x minus 18 equals 0, so that I can factor. So I'm looking for 2 numbers that multiply to 18, add to negative 3. Start each one with x. So what are my values that are going to add to negative 3, but multiply to 18? Negative 6, positive 3. Okay, great. Now, when you solve, you have x minus 6 equals 0, x plus 3 equals 0, so x equals 6, or x equals negative 3. This is where we have to check them. And I am going to show you how to check. So when you check, you really can just plug them in, okay? So if you're checking 6, sorry, that's really small. That's hard to see. Let's plug it into the original. So you have 6 minus 18 over 6 equals 3. Okay, so what's 18 divided by 6? 3. So you have 6 minus 3 equals 3. Is that true? Yes. So 6 is going to work out. When I plug in negative 3, let's see if that one works out. So I have negative 3 minus 18 over negative 3 equals 3. So we're just plugging it into the original function. This is a negative over a negative. So when you do negative 18 divided by negative 3, it does become positive 6. And that does add to 3. So your solution is x equals 6 or x equals negative 3. Both of those work. Sometimes it happens where they both work. Now, here's a clue to, you know before you even plug it back in if those are going to work or not. This is the check where you make sure that your answers are correct. But remember that the LCD, this is the denominator. If you have a fraction, what can x not be? X can't be 0 in this case, right? So when you're thinking of the domain of a function, right, you know that x cannot be 0. So if neither of these answers are 0, you should not have an extraneous solution. Okay? If one of your answers was 0, then that would be extraneous. And we will look at a situation like that. I just want you to know when you're checking, check against the domain. Okay? And if it doesn't fit, then it's good. But if it is one of the answers that you have to be careful of, that should be an extraneous solution. Okay, so let's look at part B. Okay, and then for part B, we have 6 over x plus 5 over 4 equals negative 7 over 4. And I'll just tell you ahead of time, there are multiple ways to solve this problem. I'm going to show you a new strategy for this. That's going to be something we're going to apply to the story problem, and something that's helpful when you get into more complex situations. So we're going to practice it on this one first, okay? So if we did this like we did the first one, we would identify the LCD. We're still going to do that. We're still going to identify the LCD. Can you guys tell me what it is? Yes, 4x. So again, it has to have x, has to have 4 times x. So if we were doing this like the first one, we'd multiply the top and the bottom by 4, we'd multiply the top and the bottom here by x, and then we'd have a fraction equal to a fraction, and we could cross multiply. And that would be fine. You could still do that. Like I said, I'm going to show you a new strategy that gets rid of the fractions right away. And the new strategy that you can use is, once you know what the LCD is, you can multiply both sides by the LCD. And then what happens is there's a lot of cancellations that occur. And of course, the first time you do it, it's going to feel a little bit different, but then once you practice it, the cancellations are going to be pretty quick. So if you multiply both sides by the LCD, okay, you're going to multiply this side by 4x, and you're going to multiply this side by 4x. So I'm going to keep this the exact same, 6 over x plus 5 over 4. I'm going to keep this the exact same, just to show you what I'm doing is I'm multiplying both sides by 4x. And the reason why you do that is because now you have some cancellations. So let's start with the right side, because that cancellation is going to be pretty quick. So if you multiply by 4x, this 4 cancels out with this 4. So then let's look and see what we have left. We have x times negative 7, so that's just going to be negative 7x. Okay, now you have, I put the parentheses here because I'm multiplying. This also reminds me I'm going to have to distribute. So really, I'm going to have 4x times 6 over x plus 4x times 5 over 4. So if I distribute, this is what I have. Okay, now really as you get good at this, you aren't going to have to write out this step. You're going to know what the cancellation is because you can even see here, right? The x and the x are going to cancel out. So when the x and the x cancel, what are you left with on top? Yep, good. 4 times 6, that's going to be 24. Plus, and then here, you're going to cancel out. You have a 4 on top, a 4 on the bottom. So those cancel. 5 times x. And now you can just solve this for x. Now this is different than the one we did before. See how we don't have an x squared? So we don't have to move them all to one side. We just have to get all the x's on one side, all the numbers on the other. That's how we already solved it. So we're going to subtract 5x from both sides. Okay, and then we are going to check it. Now, again, remember, I said, look at your LCD, right? So your LCD is 4x. So according to the domain, what can x not be?
4.
So remember that this is the denominator, right? So if you set that equal to 0 and solved, if 4x was equal to 0, what would x be? 0. So x can't be 0 here, right? So -2 should work. Let's check and make sure that it works. Okay, so when we check the -2, we have 6 over -2 plus 5 over 4 equals -7 over 4. So the best thing to do in this situation is not to simplify this to -3, but see how the denominators are all 4? Let's make the denominator 4 so we can compare them. So what could I multiply this by to get to 4? Yeah, and really, you guys know if a negative's in the denominator, you can just move it to the top. If you only have one negative, it doesn't matter where it goes. It can go on the top, it can go on the side, so I would just do that. And I would multiply by 2 over 2. So -6 over 2 times 2 over 2 makes what? All right, and then -12 plus 5 is -7, so yes, that works. So x equals -2 is our solution. All right, for part C, I want you to just think about what you would do first. Don't actually do it, but think about it, okay? You can write down the problem, but I don't want you to make any mistakes. Okay, what are we thinking? Yeah, get it.
I would say first we need the LCD.
Okay, so get the LCD, and we actually already have it. See how the denominators are the same? Yeah. So we have the LCD.
Just here's what the denominator talks about.
So we can. That is what we're going to do. So a lot of times you have a fraction and you're thinking, oh, I'm going to multiply each side by the denominator, right? In this case, because the LCD is the same, the denominator is the same already, if you were to multiply each side by x minus 2, what would happen on both sides? They would cancel, right? They would cancel out. X over minus 2 over itself, x minus 2 over itself. So this is similar to what we did with the bases. Okay, if the denominators are equal, okay, if the denominators are equal, so are the numerators. Because you have the equal sign here, okay? You can't have 1/2 equal to 2/3, okay? That would be false. So if you know that the denominators are the same, the numerators have to be the same too. So all you have to do now is set them equal to each other. So you can just set 5x equal to 3x plus 4. If you did show that you multiplied each side by x minus 2, that is perfectly fine. Okay, you can definitely show that. And then this is another one where you can get all the x's on one side. Okay, and then get x by itself using division. All right, now let's think about the domain. So if the LCD is x minus 2, what's the domain? What can't x be here? Okay, so when I plug this in, something should happen that makes me not be able to move forward. So if I plug in 2, I have 5 times 2 over 2 minus 2. Therein lies the problem, right? Because if you have 10 over 0, can you divide by 0? Nope. So don't do this and say, oh yeah, they're equal. Okay, because yeah, this makes the equation true, but this is the problem. You can't divide by 0. So when that happens, this is an extraneous solution. I like to think of it as it's extra. It's all, I'm the solution, x equals 2, but it's a line. It's a line to you. Okay, so do you guys know what you would write on your line? Close. You're just going to write no solution. Okay, so there's no solution that would be valid for that equation. Okay, so this would be your work, and then this would be the answer. Like if you were taking a quiz, that's what you would write on your line. Okay? All right. One more. 2x minus 5 over x minus 8 plus x over 2 equals 11 over x minus 8. So this is another one where I want you to try the process where you multiply each side by the LCD. Okay, and let's identify what the LCD is. Yeah, so whenever you do the LCD, I always start with the first denominator. So x minus 8 is in it, so yeah, that has to be part of the LCD. Okay, then I also have 2, so it has to be 2 times x minus 8. And you can leave your LCD just like this. You don't have to distribute. In fact, don't, because it'll be easier to cancel things out without it. Alright, so I'm going to keep the same thing on both sides. And I'm going to multiply each side by 2 times x minus 8. And if you wanted to, you could also do the distribution right away. In fact, that's probably what I would do instead of writing it out twice. Right, so you have 2 times x minus 8 times 2x minus 5 over x minus 8 plus 2 times x minus 8 is x over 2 equals, so you could do this as that step. That's perfectly fine. Saves you a little bit of writing. And then on this side, let's cancel out those x minus 8s right away. And then look what you have left. So it's 2 and 11. So you have to multiply those together. 2 times 11, 22. Thank you. Okay, and then here we're going to cancel those out. And then with this one, you can cancel out the 2's. You can borrow some money.
Yes, I get paid
He's not here today.
that.
Yep. Okay, so then once you cancel these out, just look and see what you're left with. So here you have 2x minus 5. So you're going to multiply those together. Here you have x minus 8 times x. I'm going to write it like this because I'm going to distribute. All right, and then go ahead and distribute there. Alright, and then once you distribute, let's start organizing what our like terms are. So we have x squared, this is 4x minus 8x, so you have negative 4x minus 10. And this is one where you have to move everything over to one side. Anytime you see the x squared and the x term and the number term, that's where we want to get our factor on. So can we factor this? All right, 1 multiplies to 32, but adds to negative 4. Negative 8, positive 4. So negative 8 plus 4 will be negative 4. Yeah. And then that's going to give you 2 answers. So when you set this equal to 0, you'll get x equals 8. Or when you set this equal to 0, you would get x equals negative 4. But I'm fine with you indicating that those are your 2 answers. And again, let's think about the domain. So remember, your domain is tied to your denominator, right? Because we have a fraction. We know this can't be 0. So the domain tells us that x would not be allowed to be what number? 8. Because if you plug in 8, that would make this 0. So when you're checking this, what's going to happen with one of your solutions? Yeah, it's not going to be possible. Okay, so when you do your check for x equals 8, this is going to be extraneous. If you plug in 8, you would get 2 times 8 minus 5 over 0. Anytime you have this, you can't divide by 0. And I'm fine with you like showing that plug-in and explaining why that's a problem. So this is extraneous. Okay, let's see if negative 4 works. And let's do this in our head, okay? So 2 times negative 4 is negative 8. Negative 8 minus 5, negative 13. And then negative 4 minus 8 on the bottom is negative 12. So when I say do it in your head, like you don't have to write out the negative 4. You can just plug that in as you go. Plus negative 4 over 2. And equals 11 over negative 4 minus 8, which is negative 12. So let's just make this so the denominator is 12. And a negative over a negative simplifies to what? positive. So this is really 13 over 12. If you multiply this by 6 over 6, you get 12 on the bottom, negative 24 on the top. And like I said, this negative, you can just move it to the top. 13 minus 24 is negative 11, so that does work. So you had two solutions. One of them is extraneous. Your only answer is x equals negative 4. Okay, so that's what you would put on the line, is x equals negative 4. Okay, so the domain is very important. The domain tells you what you have to watch out for, okay?